In terms of the biggest limitations or hurdles in doing a good machine learning from an oil and gas perspective is in oil and gas we have data which is coming from the subsurface which gets affected by noise. Data is coming from a lot of different sources, and plenty of times some of these data sources can go offline. So we have a lot of missing data with a lot of outliers. We have to know how to handle these missing data and outliers before we develop any machine learning algorithm. So that's problem number one, which is a hurdle in developing good machine learning algorithms. Then comes the problem of extracting features. We have data, but this data needs to be processed through some feature extraction algorithms. By extracting the features and then feeding these new features to the machine learning algorithm, we can develop better data-driven models. So other challenges of machine learning includes the fact that plenty of times when we develop these machine learning algorithms, they tend to overfit. They tend to kind of match your data. They tend to overfit the data. To know when your model overfits and to know how to reduce this overfit will help you develop robust machine learning algorithms. Another challenge is to know the limits of the machine learning algorithm. When I talk about supervised learning, when I talk about unsupervised learning, there are a lot of different methods there. Each method has a limitation. Each method is based on some concept, some fundamental concept, how that algorithm works. To understand that will help you create better models. Once you understand this basic concept, then you can create your own models. A lot of softwares don't give you flexibility of creating your own models. It's very difficult to figure out when does your model perform as you expect. Plenty of times the model will appear that it gives you the result that you want, but you need to follow a certain workflow to know that you have built a robust machine learning model. Finally, we are in this era where we have moved into deep learning. When we do deep learning, we are developing deep neural networks. We can control the architecture, we can design our own architecture. So how to harness the power of deep neural networks, especially in a data constrained environment, is some of the challenge that is still pending and we need to resolve it. I'll be teaching a 2-day course on machine learning for subsurface characterization and engineering. This is a 2-day course and it will be pretty hands-on. We'll be working with Python, we'll be working with TensorFlow, we'll be working on Jupyter platform. So this is a pretty hands-on environment. We'll go through different modules. I'll show how these modules work. We'll analyze a lot of different data. Some of the data applications will be classifying reservoirs into different groups. Other applications might be in the domain of image analysis, how to extract features and then make some meaningful predictions out of those features. Other application would be if you have missing data, how to handle it. If you want to create a log or if you want to synthesize a measurement which you don't have, how to do that. So these are some of the applications we'll look at in a very hands-on way in the 2-day course. There won't be a lot of presentations. It will be very interactive where we'll be running through the modules, processing the data, generating results, and then looking at the method that help you generate the results using that data. So we'll focus on applications throughout the 2 days of course.